continuing with, I'm going to slide some new paper here, Unit 6, Day 5. This is Algebra Honors. Unit 6 is on exponents and radicals. So we're working on simplifying radicals when we are simplifying cube roots that are the cube root of something that's not a perfect cube. So there is a video out there where we start with the basics, and this is our second video on cube roots. This time we're going to talk about cube roots of negative numbers. Okay, remember, we can't take the square root of a negative number, right? We can't take the square root. We cannot have the square root of -4 in this class because there's, it's not okay to do that because there's no way. You either have to have 2 times 2 or you have to have -2 times -2 if you have the square root, right? You need your factors to be exactly the same, and we can't do that. So we can't have a square root of a negative number in this class. You'll be able to do that in higher math classes. Okay, we can, though, have the cube root of a negative number, okay? So if we wanted to simplify -8, the cube root, I need to know what times itself gives me -8. So if we think about that, my answer is -2, because -2 times -2 times -2 equals -8, right? -2 times -2 is +4, times -2 is -8. So if you're taking the cube root of a negative number, just realize that your factors, your final answer is going to be a negative number. And here's why, because we love to prove these things to you, right? If I want to take the cube root of the negative of a, I really want the negative of the cube root of positive a. That's because the negative a right here, it has an invisible 1, right? So I'm going to have -1 under the radicand, and I'm going to pull -1 out. The cube root of -1 is -1. And then I'm left with the cube root of a, right? This is going to be the cubed root of -1 cubed times the cube root of a. Cube root of -1 is just -1. So it's -1 times the cube root of a. All right, so every single time I know I'm going to have some sort of a negative number here, I can pull the negative out first if I want to, right? Because the cube root of -1 is just -1. So this equals -1 times the cube root of 81. Okay, so now I need to figure out my factors of 81. I want to find out what is the cube root of 81. And I'm going to look back at my first page where I wrote down a whole bunch of perfect cubes. Because I know 81 is special, but no, 81 is a perfect square, not a perfect cube. But if I look at these, this 27 catches my eye. I think 27 goes into 81, right? So I'm going to write this as -1 times the cube root of 27 times 3. Okay, if I didn't know that just by thinking about it, I can divide whatever my radicand is by perfect cubes. So I'm going to try dividing it by 27. And if I get an integer as my answer, then it means that I can break it up into those two factors. Okay, the reason I'm doing that is now I have -1 times the cube root of 27 times the cube root of 3. So I have -1 times, well, 3 times 3 is 9, times 3 is 27. The cube root of 27 is 3. And then I'm still times the cube root of 3, right? If I needed to do that on the calculator, cube root of 27, I put in 27. I want second function 0. And that's going to give me 3. That's my answer there. Okay, I'm nearly done, right? I just need to simplify that and make that look like a mathematician would write it. So this is -3 times the cube root of 3. Okay, you don't have to pull that -1 out first if you just happen to already know that what your negative factor is going to be. I probably will pull it out just so I can be working with positive numbers. So here, the cube root of -128, I'm going to say it's -1 times the cube root of +128. Okay, I know 8 would go into 128 evenly. 8's a perfect cube, but let's look. Oops, sorry, it's on the other page. Let's look at some of our perfect cubes. 64 is an even better option, right? It's a bigger perfect cube. So I'm going to say -1 times the cube root of 64 times 2. Okay, the reason I did that is now I can say -1 times the cube root of 64 times the cube root of 2. So I have -1 times 4, because the cube root of 64 is 4. 4 times 4 is 16 times 4 is 64. Times the cube root of 2, which can't be simplified anymore. So my final answer is -4 times the cube root of 2. Okay, over here I'm going to take out that -1, so I have -1 times the cube root of 32. So I think 8 is probably my biggest perfect cube in here, but let's pretend I couldn't figure that out just by looking. So why don't we do this factorization method, okay? So I'm going to find the prime factors of 32. So I have 2 times 16, and I have 2 times 8, and I have 2 times 4, and I have 2 times 2. These are 2 times 2 times 2 times 2 times 2. And if I do all that multiplication, I do get 32. Since I'm looking for cube root, I'm going to looking for triples to pull them out. I can pull this triple out. Those guys can go out and play. Okay, so they go out and they work as one unit on the outside of the house. They are going out to play together. What I still have in my house that didn't get to go out because it wasn't a triple, I have 2 times 2. So I'm going to multiply that back together and get 4 again, right? So 2 times the cube root of 4 is what I have if I break up the cube root of 32. And I still have -1 times all of this, right? Because I pulled that -1 out. So my final answer is going to be -2, because -1 times 2 is -2, times the cube root of 4. Voila, comme ça. Okay. Please try these practice problems, put the video on pause, check your answers either one at a time, or you can come back and check a bunch in a row. That way you can just kind of fast forward or skip through my explanation if you got it correct, okay? For each of these, I'm going to think about whether I can find a perfect cube. These are cube roots. If I can find a perfect cube, then I'm going to rewrite with a perfect cube and simplify. So pause now and then come back and check your work. This is going to be the cube root of 8 times 3. 8 times 3 is 24, and I know 8 is a perfect cube. So it's the perfect cube, it's the cube root of 8 times the cube root of 3. Cube root of 8 is 2, so it's 2 times the cube root of 3 as my answer. Over here, this is going to be a negative on the outside, so I'm going to say that's -1 times the cube root of 54. So that's going to be -1 times the cube root of 27 times 2, because I just wrote down a whole bunch of perfect cubes, so I remember 27 was a perfect cube. And I recognize that 54 is evenly divided by 27. All right. Now I'm going to rewrite that as -1 times the cube root of 27 times the cube root of 2, which is -3 times the cube root of 2, right? Because I have -1 times +3 is -3. Woof, 15, 12. Let me look for one of my big perfect cubes. I'll try 729 first, just in case. Okay, so I'm going to say 15, 12. Sorry for the glare. 1512 divided by 729. Ah, that is not what I want. See how that gave me a big decimal? Okay, that didn't go in evenly. So let's look. Let's try 512. I don't know. 1512 divided by 512. Also a big decimal. I don't want that. That is not a factor that I want. I'm going to try 343 and see if that works. Okay, 1512 divided by 343. No way, man, that's still a decimal. So let me try another one. 216. Okay, 1512 divided by 216. Ha! That's what I want. See how I got an integer there? So I know the square root of 1512 is 216 times 7. 216 times 7. Okay, so I just kept dividing and trying to find which one of those perfect cubes is a factor of 1512. So that's yet another method, lots of ways to do these problems. Okay, I did that because now I have the cube root of 216 times the cube root of 7, which is 6 times the cube root of 7 as my final answer. I got a negative, so I'm going to pull that negative out. I have -1 times the cube root of 125. 125 is actually a perfect cube. Now that I'm thinking about that, I probably didn't even need to take the -1 out. Here's why. And if you ever suspect you might have a perfect cube, put it in. Okay, let's put in 125 and make it negative using this key down here. I'm going to take the cube root, so I'm going to go second function on that 0. -5. Okay, so I could have just done that in a calculator and gotten -5 as my answer. Since I didn't, I have -1 times the cube root of 125. The cube root of 125 is, just 5. So -1 times 5 is -5. That is my answer. But if you notice that you think it might be a perfect cube, go ahead and put it in the calculator. All right, -45. I don't know about that. It's not divisible by 27. It's not divisible by 8. So I can pull a -1 out, right? And then it's going to be times the cube root of 45. But I can't really divide that 45 out anymore. Just for kicks, I'm going to try it with factorization, right? So 45, I know that I can do 5 times 9. 9 is 3 times 3. Yeah, there aren't any triples here, right? There's a singleton and there's a pair, so I can't pull any triples out. I don't think I can do any more than that. So I'm going to say that's my answer. Please do pull the negative out when you're giving us an answer because we prefer not to have negatives inside our radicals. Okay, number 6. Oh, I have the cube root of 600, so I'm going to pull my little chart back. Do we think 600 is divisible by 125? Maybe. 600 divided by 125. Ah, hooray! No, that's 4.8. Shoot. Thought that was going to work, but no, it did not. So it's like a cube root of 600. Maybe that's divisible by 8. Let's check it out. 600 divided by 8. 75. Okay, so that worked for me. 8 times 75 is those are factors of 600, sorry. So if I say that this is the cube root of 8 times 75, I know that that is 2 times the cube root of 75. Well, 75 feels like it ought to be a perfect cube. We know it's not, but I'm just going to check. 75, just in case. Second function, 0. No, it gave me a decimal, so it's not a perfect cube. So I'm just a little bit nervous. I want to make sure I get all the way as small as I can. So I'm going to factor this guy out. 5 5 goes into 7 one time, 5 goes into 25, there you go, 5. 15 is 5 times 3. So these are all prime numbers, but just like last time with my 45, I have a pair of 5s. I don't have any triples, so I can't make that any better. So that is my final answer. All right, so I've flipped my page over. So much to remember. So much to remember, and so I'm going to say, as we're looking at radicals, be sure you're looking to see whether you see a square root or a cube root. Okay, and so we're going to put all of these problems here into simplest form. Okay, so there's one more piece of information I have to give you. I told you the product rule, and this works for cubes also, right? So the square root of a times b is the same thing as the square root of a times the square root of b. It's the same thing as cube root. Okay, I can break that up. It's the cube root of a times the cube root of b. So both of those things are true. The quotient rule, it's the same idea. If I have the square root of a fraction, I can break it up so that I have the square root of the numerator over the square root of the denominator. And that is also true of cube roots. Okay, so if I have the cube root of a over b, I can break that up so that it is the cube root of a over the cube root of b. All right, so let's start simplifying. I have here a fraction. Okay, it's the square root of 3/4. So I'm going to break this up so that I have the square root of 3 over the square root of 4. Well, that actually works in my favor because I know the square root of 4. So this is the square root of 3 over 2. I can also write that as 1/2 times the square root of 3. That's up to you. Number 2, I'm going to break this. Oh, you know what? I could simplify if I want. Why don't I simplify first? You don't have to, but I can simplify here first because that is going to equal the big square root of 2 goes into 32 16 times, and 2 goes into 50 25 times. Now when I break that up, I have the square root of 16 over the square root of 25, and that's 4/5. If you didn't notice that you could simplify, no big deal. You have the square root of 32 over the square root of 50. So I'm going to show you what happens if you didn't see that you could simplify beforehand. Square root of 32 is just a little bit more work, right? Square root of 32, I know that that's 16 times 2 in there. So I'm going to say that that equals the square root of 16 times the square root of 2, yeah? Over this, I'm going to say is 25 times 2, so square root of 25 times square root of 2. Fantastic. I know that this equals square root of 16 is 4, square root of 25 is 5, and anything divided by itself, as long as it's not 0, poof, it equals 1. Okay, so I get 4/5 either way. You just want to simplify all the way down. So probably it's easier to simplify inside the fraction or inside the radicand if you can. Okay, alert, alert, alert. We're going to do a cube root now. So this is going to be, I don't see a quick way to simplify this, so I'm going to say that that's the cube root of 27 over the cube root of 125. Well, I remember from my handy chart that these are both perfect cubes. So the cube root of 27 is 3, and the cube root of 125 is 5. Okay, you can also try that on your calculator if you don't remember, just to double check. Okay, we are back to square roots over here. The square root of 5 times the square root of 10. So the main way I'm going to do this is say that that is the square root of 5 times 10. So I'm going backwards with my product rule, right? Mostly we've been breaking things up, but this time I'm smushing them back together again. So that equals the square root of 50, which, yay, is the square root of 25 times 2, which is the square root of 25 times the square root of 2, which is 5 roots of 2, right? Okay, that's all I'm going to say about that. There are a couple other ways to think about that one too, but we're going to leave that there. All right, I'm still with square roots here. Square root of 2 times square root of 8. I'm going to smush them together, and I get the square root of 16, which I know is 4. Okay, here's another way to look at this, which I could have said on the last problem as well. You know that this is the square root of 2 times the square root of 2 times the square root of 4, right? Because the square root of 8 is 2 times 4. Square root of 2 times 4. Anytime you have the square root of something times the square root of the same thing, so square root of 2 times square root of 2, you know that that answer is 2, right? Square root of 2 times square root of 2, the answer is 2. And you know here the square root of 4 is 2, so 2 times 2 is 4. So there are several different ways that you could end up. Sorry, my big messy pen there. Several ways that you can end up with 4 as your answer. So you're going to kind of manipulate these problems the way you feel most comfortable. 2 times the square root of 8, it's square root, not cube root. Okay, so I'm going to say that equals 2 times the square root of 4 times 2, because 4 times 2 is 8. That's 2 times the square root of 4 times the square root of 2. So that's 2 times 2 times the square root of 2. And so that's 4 times the square root of 2 as my final answer. This is different from this guy, right? Because this we wanted the square root of 2 times the square root of 8. Here we just already had 2 on the outside. Okay, 3 times the square root of 2 times the square root of 18. It's the same as 3 times the square root of 2 times 18. I'm putting them back in the same house. It's 3 times the square root of 36. So it is 3 times 6, which is 18. Woohoo! Okay, 3 times the square root of 2 times the square root of 6. I'm going to look at this a little bit of a different way. I could multiply 12 times 6 and get 72, but I'm going to say that this is 3 times the square root of 6 times the square root of 2. You buy that? Times the square root of 6. Okay, and I did that because we said if we are multiplying a square root of something times itself, right? Square root of 6 times square root of 6 really equals 6. So I'm multiplying those guys together. I have 3 times 6 times the square root of 2. And that's 18 square root of 2. That is my answer. If I had done it the other way, totally fine, right? I would have had 3 times the square root of 72. 12 times 6 is 72. And I need to break that up. I know that that is... well, I know it's 9 times 8, but 9 is a perfect square, and 8 has the perfect square of 4 in it. So I wouldn't be all the way done. Well, why don't I just do it that way? This is 3 times the square root of 9 times the square root of 8, right? So it's 3 times the square root of 8. So it's 9 times the square root of 8. But here's one of the things you need to be careful with. Square root of 8 is not all the way done, right? I can get a perfect square out of there because 8 is 4 times 2. So this is really 9 times the square root of 4 times the square root of 2. Yeah, 4 times 2 is 8. So this is really 9 times 2 times the square root of 2, which equals 18 square root of 2. Please let that be what we came up with before. It is. Whoo, lucky me. Okay, so again, with all of these problems, you have lots and lots of ways to work through to an answer. And so if you're choosing to go a different route from me, that's totally fine. If you are working through using a different method and you need clarification on it, please feel free to email because I know lots of ways to do this and I'm happy to work through. If you're using a different method, I'm happy to help you. All right, we're back to having a fraction as our radicand. So I'm going to break that up into the square root of 5 over the square root of 16. Okay, and square root of 5 can't change, but square root of 16 I know is 4. And my last problem, number 10 here, cube root of 2 times cube root of 4. I'm going to smush them together and put them back under the same house. It is the cube root of 8. 2 times 4 is 8. And 8 is a perfect cube, so the answer is 2. Since it's cube root, I'm going to show you this is also cube root of 2 times the cube root of 4. I can split it up. It's the cube root of 2 times the cube root of 2, right? Cube root of 4 is cube root of 2 times cube root of 2. Well, since this is cube roots, I want 3 of the same thing. I have 3 of the same thing. I have the cube root of 2 3 times. So I know that my answer is whatever is in there that I had 3 times. So my answer is 2 that way. Okay, so it's kind of just a different way to look at it. But all right, thanks for following along for Unit 6, Day 3. And by all means, if you found any errors as I was going through those notes, send me a message, come by, and I'll see if I have a Jolly Rancher for you. Thank you.